Hi, I will be helping you today with finding the perimeter of a triangle. Triangle ABC has vertices 0, 0, 3, 2, 0, and 4. What's the approximate perimeter of the triangle ABC? Either you find the distance formula between each every two vertices, like this is one length and this is one length, and this is the third length, so you have three different points, or you find the length of each one using the distance formula, or just go back to your grid paper, make an x-axis and y-axis, try to graph it and estimate the length of the triangle. Let's plug the points here, 0 and 0. The second point, this is A, 3 and 2, 1, 2, 3 and 2. The third point is 0 and 4, 1, 2, 3, 4. So now you have this triangle from here to here, from here to here, and from here to here, this triangle here. What is the approximate perimeter on this one here? Okay, from here to here we know there's 1, 2, 3, 4. So there are 4 points here. The length in this side here is 4. Let's call this is point C and this is point B. Okay, from here to here, I see this one is an isosceles triangle because I see there's from here to here is the same distance as from here to here. From B to C is the same as from A to B. Okay, let's find from A to B. You have two choices to do this part. Either use the Pythagorean theorem or the distance formula to find it, or just estimate it if you forget both of them. Try it, right, like a right triangle like this, small right triangle, okay? From here to here is 1, 2, 3, and from here to here is 1, 2. Okay, so triangle, let's just graph it here, a right triangle. This is 3, this is 2, find the hypotenuse x. We know c squared equals a squared plus b squared. So c squared is the x squared equals 3 squared plus b squared, which is 2 squared. That is going to be 9 plus 4, and that's x equals square root of 13. 9 plus 4 is 13. You take the square root of both sides, you get square root of 13. Get x equals square root of 13. So AB is the square root of 13. And this one is the same thing, because if you have a right triangle like this, from here to here and from here to here, you get 1, 2, 3, and this is 2. So that is going to be the same. You'll have the same, of course, hypotenuse. So each one of them is going to be square root of 13. So you have 4, the perimeter, 4. Perimeter is exactly like a fence. If you have a garden in this shape, right, a triangle like this, and you want to buy a fence to your garden, so in order for you to find that, or before you go to, let's say, Home Depot or something, you need to measure the length of each side of your triangle of your garden. That's the perimeter. 4 plus square root of 13 plus square root of 13. When you get a question like this, you're not going to get an obvious numbers, most likely, because they just want, the people who put this test want to test your ability of like making, are you able to make sense of numbers, square roots or not? That's the bottom line. And of course you're going to have like a calculator. That time is going to be active calculator. Okay, try 4 plus square root of 13. I like to do everything step by step like this. Plus square root, instead of multiplying 2 times square root of 13. And make sure you close the parentheses after the first square root of 13, so you don't mix them. That's going to be 11.2, and this is, when you approximate this one, is going to be 11, not 12. Okay, so the choice B is the right choice. This is the approximate parameter. This is one way. The other way to find the perimeter is using the distance formula. I'm going to just erase everything here. without graphing it, which is like a little bit longer, but I'm just going to mention it here. The distance formula of each vertex y2 minus y1 squared plus x2 minus x1 squared, and you close the square root. Okay, you pick this length here, or this one here. This is x1 y1 x2 y2, and you find the d equals the square root of x2 y2 minus y1 y2 is 2 minus 0 squared plus 3 minus 0 squared, and that's going to be square root of 2 minus 0 is 2, 2 squared is 4, 4 plus 9, 3 squared is going to be 4 plus 9, that's going to be square root of 13. This is the first one, distance between AB. This is distance of AB. Now we find the distance of AC. AC equals square root of y2 AC. So let's erase this one here, and let's make this one x2 y2. We need to find AC. So y2 in this case is 4 minus y1 is 0 squared plus x2 is 0 minus 0 squared. That's going to be square root of 4 to the power of 2 is 16. And of course 0 minus 0 is 0 squared is 0. So square root of 16 equals 4. This is the first one. This is the second one. The third side, you got AB, you got AC. Now you need BC. The distance of BC equals square root of BC. Let's erase this one and call this one x1 y1. This is x2 y2. It does not matter if it's this one x1 y1, x1 y1. It doesn't matter which one is x1 and which one is x2. So x2 y2 minus y1, 4 minus 2 squared plus x2 minus x1, 0 minus 3 squared. Close the square, so that's going to be square root of 4 minus 2 is 2 to the power of 2 is 4, plus 0 minus 3 is negative 3, negative 3 to the power of 2 is positive 9. Also check your answer with the calculator, equals square root of 13. Now with the parameter, you add this one plus this one plus this one, which is the same thing as graphing it. So the parameter equals the square root of 13 plus the square root of 13 plus 4, which is going to be around 11, approximately 11. And that's it. Work well.